Alright, so we are going to try to sketch a curve using the derivatives. With the derivatives, we're able to find certain elements of the curve, minimums and maximums, and inflection points. So, the function that we're given is right here. It's y equals 2x cubed plus 3x squared minus 12x. So if I'm going to be trying to draw a function with derivatives, the first thing I do is I find the derivatives. So in this case, it's pretty easy, right? It's just power rules. So 2x cubed plus 3x squared minus 12, that becomes 6x squared plus 6x minus 12. And I also find the second derivative because the second derivative is also helpful in order to sketch the graph. So we have these three functions. So what are some features of a graph that are helpful to know in order to accurately sketch it? Well, first thing that comes to mind for me at least is the x-intercept. So we want to find what values of x will give us 0. Like what number can I put in for x in order to get it to equal to 0? So first of all, obviously x equals 0 will make x equal to 0, right? Because every single term has x. So 2 times 0 cubed, well, 0 times anything is just 0, plus 3 times 0 squared, again, 0 times anything is just 0, minus 12 times 0, which is just 0. So you get 0. Now, if you factor out x out of the equation here, you end up with a regular old quadratic right here, 2x squared plus 3x minus 12. And if you remember from, I think we did this last year, and also in high school or secondary school, you can do the quadratic equation in order to find the other values of x that will make this equal to 0. So that's what I did, right? So negative b plus minus the square root of b squared minus 4ac divided by 2a. I have that memorized. You might not. If you don't, then don't worry about it too much. There's a good chance that you won't even have to do this. You could just factor it anyways to find the intercepts. But this is helpful to know. So I would suggest trying to memorize it. If you just use it a few times in a few questions, it'll probably stick in your head. So using this, I'm able to find the other two x-intercepts. I'm not going to go into detail on how, that's, like I said, that was taught a while ago. By the way, so throughout these videos, I've said a few times, like, oh, you should know this, whatever. But if you don't know something, right, if you don't understand why I did something, feel free to, comment or just contact me directly asking, what happened, why I did that, explanation. I'm happy to explain. I might not get back to you right away, but I'll try to get back soon. So with that being said, I'm just going to say that I found these two x-intercepts using the quadratic equation. X equals 0, 3.623, and negative 3.312. Those are our three x-intercepts for this graph. So next, what do we got? Okay, so when f prime or y prime is equal to 0, that indicates that at that point in the graph there is either a local maximum or a local minimum. What is a local maximum? Well, okay, I drew this graph here. Obviously, you can't draw it now given what we've solved so far together, but let's just ignore that. So local maximum looks like this, right? It's when the point reaches a high and then it goes back down. And a local minimum is the exact opposite. It's when a point reaches the lowest and then it goes back up. So like I said, whenever you have, y prime is equal to 0, that means you have either a local maximum or a local minimum right there. So our y prime is equal to 6x squared plus 6x minus 12. So here I factored the 6 out. So I end up with 6 times x squared plus x minus 2. And here I do some factorization in order to find the factored form of this quadratic equation, right? Because this is a quadratic, right? 6x squared plus 6x minus 12, that's a quadratic. Again, I'm not going to go over how I did that, right? Hopefully you'll know, and if you don't, then feel free to contact me. But I factor this, and then I end up with 6 times x plus 2 and x minus 1. X plus 2 is equal, and of course I want to find the values that will make this equal to 0. So I do x plus 2 equals to 0, x minus 2, x minus 1 equals to 0, x equals 1. So I have these two values. At these 2 points, we have either a local maximum or a local minimum. We don't know yet. We have to do more to figure out if it's a local maximum or minimum, but we have that knowledge. And but however, these are just the values. Like, this is the x value at which we find the local maximum or minimum. We don't actually know where specifically the local maximum or minimum is yet. So what we're going to do is we're going to take one of these x values, -2, and we're going to plug it back into our original equation. And so I did this down here. Y equals 2 times -2 cubed plus 3 times -2 squared minus 12 times -2 equals to 20. So we know that at this point, right, either the local maximum or local minimum is at -2, 20. So we have that point, we'll be able to put it down later. And the same thing with x equals 1. I plug in 1 and I find -7. So we have those points. And now we have x-intercepts, which we found in the previous step, and now we also have these minimum and maximums, which we just found. We don't yet know if they're minimum or maximum. That comes in the next step, but we have all those points. So to figure out if these are minimum and maximums, we're going to do another rule, which, by the way, I have the rules written right here. So what we're going to do is we're going to take the second derivative, 12x plus 6, and we're going to plug in these values where the local maximum minimums are. So we're going to plug in x -2, and we're also going to plug in x1. So for x -2, we end up with -18. So if, when you do this, when you plug in the number into the second derivative, if the number you get is negative, that means it's a local maximum. They're written right here. Now, if the number is positive, which was the case when we plugged in x equals 1, then you have a local minimum. Professor taught us something called, I think, the rain collection trick. So the reason why a positive is a minimum. So if you have a minimum, right, this is what a minimum looks like, right? It's like a bowl going down. So if you have a minimum, then you will be able to collect rain, which is why it's positive, because you're getting rain. And then it's the other way around if you have a local maximum, right? You're not collecting rain, which is why it's negative. If that helps you remember, it actually did help me remember, so if it does, then that's great. But either way, just, that's how it works. And so one more thing. So at this point, we have almost everything, right? We know where the local maximum minimums are. We know which one is a local maximum, which one's a local minimum. And we also know all the x-intercepts. There's one more thing we can find, which is the inflection point. So when the second derivative is equal to 0, you can find something called an inflection point. Now, what an inflection point is kind of difficult to describe. It's basically the point at which the graph starts to change direction. So if your graph is like sloping downwards and then it starts curving back up, the inflection point is the moment at which it starts to curve in the opposite direction. So that can also be helpful for your drawing of the graph. So we're going to find when this is equal to 0. I did it right here. 12x plus 6 is equal to 0. So move the 6 to the other side, you get 12x is equal to -6. Divide both sides by 12, you get x is equal to -6 over 12, or -1 over 2. So that's the x value at which we find the inflection point. And then over here, I plug in that x value into our original equation, and I find the y value, 6.5. So at this point, we have everything we need. We have all 3 x-intercepts, we have both of the maximum/minimums, and we have the inflection points. So now you can, draw all those dots down on your graphing paper or whatever, and then you just connect them with a line, and there you go. You have the drawing of the graph. It'll be obviously it won't be perfectly accurate, right? Because you're just drawing it by hand, and you only know a few points, but it'll be pretty good as long as you find all this information: x-intercepts, local minimums and maximums, and the inflection point. You'll be able to make a drawing that's accurate enough for a question that asks for this information. And that's it.